The Leave plan of room specialists has found that, using our new $101 billion toy, it will be apparently everlastingly. Prior to that, a trial becomes a reality. On the remote possibility that it goes well, the excursion to Proxima b will proceed as planned. Expect it to take close to 20 years, so it will be a few years before we can anticipate whether that planet has particular life. The published studies on whether or not we are really alone in this universe persevere. Through the James Webb Telescope, scientists have discovered some incredibly humanesque things far away from Earth that lead us closer to the answer. Our mission for life beyond us has been an obsession in every individual action, to such an extent that we have countless media works and speculations regarding this issue. Our wonder about our position and significance in the universe has always been deeply ingrained within us, leading us to search for a mate, despite how similar or different we might be. We might be getting progressively closer to the answers we seek. Were they truly our answers? Are we looking for truth, or are we simply unsettling ourselves? Join us as we dissect the most progressive advancements in the study of planetary systems on the journey to track down something we likely won't be prepared to observe. Distant lights. Experts have discovered what may be the most important revelation of the past. In the year 2021, when the James Webb Space Telescope was scheduled to launch, an exceptionally intriguing theoretical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on a different planet, such as Proxima b, the nearest exoplanet to Earth. Proxima b, located about 4.25 light-years away, was recognized as being tidally locked with a permanent day side and night side, much like our moon. A hypothetical technological advancement for Proxima b could involve moving power and energy from the day side to the night side using photovoltaic cells that generate electricity from starlight. Subsequently, in a research paper with Manas V. Lingam as one of the researchers, it was shown that a vast array of solar panels on the day side could be detectable by future telescopes. Because the JWST is highly advanced, it enables us to broaden our search for artificial lights on exoplanets like Proxima b. Now, what if the James Webb Space Telescope actually did just that in 2024? Utilizing its heightened sensitivity and superior capabilities, the JWST might have tracked down the artificial lights we were searching for, potentially triggering another significant uptick in human curiosity and exploration. Let's dive into the universe of planets and exoplanets to understand how this could even be possible. Research for James Webb's mission. The mysteries of Proxima b. From the beginning of recorded history, people have pondered the possibility of life beyond Earth. Who are we? Where do we come from? These fundamental questions have always intrigued humankind. But with our increasing technological advancements, are we any closer to answering them? If you ask a philosopher, he might say we are still at level 0 in understanding ourselves and the universe. However, if you consult an astronomer, watch as he eagerly shares the latest discoveries made using advanced technology. The opinions of the public often reflect scientific progress. We now have the world at our fingertips, and it's time to push forward and bring the universe within our reach. One way to achieve this is through technological innovation. A crucial aspect of this innovation is our preparedness for the next big discovery, possibly detecting artificial light on a planet light-years away. Yes, we're talking about the James Webb Space Telescope. The JWST is a product of human ambition, designed to address some of the most persistent questions. Are we alone? Who or what is out there? Where does life begin and end? This infrared astronomy device has already begun searching for answers. But first, let's clarify. What exactly is Proxima b? Proxima Centauri b, or simply Proxima b, is sometimes mistakenly referred to as Alpha Centauri. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths might sound confusing, but don't worry. This text will clear up your doubts. Super-Earths are planets that are more massive than Earth, but lighter than Neptune and other ice giants. They can be made of gas, rock, or a combination of both, with sizes ranging from twice Earth's size to several times its mass. Since Proxima b is an exoplanet, it means it orbits a star outside our solar system. The first possible evidence of an exoplanet was found as early as 1917, though it didn't attract much attention. However, in 1992, the first confirmed exoplanet discovery left scientists astonished. Another exoplanet, first detected in 1988, was officially verified in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems having more than one planet. Many of these discoveries are associated with M-type stars. Understanding M-type stars and red dwarfs. To comprehend M-type stars, you first need to understand red dwarfs. A red dwarf is the smallest type of star on the main sequence. These stars are, by far, the most common type found in the Milky Way, but they have extremely low luminosity. Since luminosity is one of the primary ways we detect planets, red dwarfs are challenging to observe. These faint stars have various classifications based on their temperature and size. For example, M-dwarfs, M-type main sequence stars, have a maximum temperature of about 3,000 Kelvin. As for Proxima b, its mass is nearly identical to Earth's, at approximately 1.07 Earth masses. Interestingly, one orbit around its star takes just 11.2 days, much shorter than Earth's 365.25-day orbit. To measure the star Proxima b orbits, scientists analyze the entire electromagnetic spectrum. Proxima Centauri's total luminosity is only about 1.6% that of the Sun. However, in the visible light spectrum, its brightness appears even lower, emitting just 5% of the light our Sun does. The question of whether Proxima b can support life is a significant one. Due to its close proximity to its parent star, the planet is subjected to intense stellar radiation and solar flares. Red dwarfs, like Proxima Centauri, are known for their unpredictable activity, emitting powerful flares that could strip away a planet's atmosphere over time. However, if Proxima b has a strong magnetic field and a thick enough atmosphere, it might be able to protect itself from these harsh conditions. Scientists speculate that if the planet has liquid water, it would likely be located in regions where temperatures are stable, perhaps in the twilight zone between its permanent day and night sides. Another crucial factor is the presence of greenhouse gases, such as carbon dioxide, which could help regulate temperature and sustain a habitable environment. If Proxima b has a dense atmosphere rich in these gases, it could potentially support some form of life, whether microbial or more complex. Searching for artificial light on Proxima b. One of the most fascinating possibilities in the search for extraterrestrial intelligence is detecting artificial light on distant exoplanets. If an advanced civilization existed on Proxima b, it might use artificial lighting on its night side, just as humans illuminate cities on Earth. The idea of searching for artificial light was first proposed as a method for detecting technologically advanced life. In theory, a planet like Proxima b, which is tidally locked, could show a distinct pattern of illumination, bright on the day side due to its star and possibly illuminated on the night side by artificial lights. The James Webb Space Telescope, JWST, with its advanced infrared sensors, has been scanning Proxima b for any unusual light signatures. If the telescope detects an unnatural brightness pattern, it could indicate the presence of artificial structures or technologies. This would be one of the most groundbreaking discoveries in human history. What if we find signs of life? If Proxima b, or any other exoplanet, shows signs of life, the implications would be profound. Humanity has long wondered whether we are alone in the universe. The discovery of extraterrestrial life, even if it were microbial, would confirm that life can arise in multiple places, making it more likely that intelligent civilizations exist elsewhere. If we detect artificial light or other technological signatures, the next challenge would be communication. Would we attempt to send a message? Could we even comprehend their language or method of communication? These are questions scientists are already considering, as the possibility of discovering extraterrestrial intelligence grows more realistic. The future of space exploration. The study of exoplanets is advancing rapidly, with new telescopes and space missions planned to further explore habitable worlds. The upcoming Extremely Large Telescope, YELT, and the LUVOIR, Large Ultraviolet Optical Infrared Surveyor, will push the boundaries of our ability to detect biosignatures and artificial signals from distant planets. Proxima b is just the beginning. As technology improves, we may soon identify multiple planets with conditions favorable for life. Whether or not we find extraterrestrial civilizations, our search will help us better understand our own place in the cosmos. The universe is vast, and our journey to uncover its secrets has only just begun. Much lesser amount of light energy compared to the sun. Over 85% of its emitted energy is infrared radiation. Revolving around 0.045 to 0.056 Australian dollars from its star, Proxima b's discovery was reported back in 2016. You might ask, why is Proxima b, among millions of stars, planets, and galaxies, of such interest? Well, there are several reasons that contribute to astronomers' interest. Specifically, Proxima b is the closest known star to our Sun by definition. Although 4.2 light-years is a big number to us Earthlings in the grand scheme of the universe, it is a simple blip. So, why is Proxima b our closest known star? High on the priority list right now. It is part of the triple star system called Alpha Centauri. In addition, notwithstanding Proxima's glow being very low, the system itself appears as one of the brightest celestial bodies in the night sky, just behind two others called Sirius and Canopus. Anyway, the most charming thing about Proxima Centauri b is that it could truly be livable, as it falls within the habitable zone. The possibilities surrounding the star are endless, and therefore, space experts have assumed the task of exploring the depths and limits of the star's validity. Likely, this is where the James Webb Space Telescope, JWST, comes in. The four main goals of the JWST are: 1. To look for light from the first stars and galaxies that formed in the universe after the Big Bang. 2. To concentrate on the universe's evolution and development. 3. To understand star and planet formation. 4. To focus on planetary systems and the origins of life. As the JWST continues its examination of the said exoplanet, we draw closer to the pinnacle of these missions, from searching for exoplanets to looking for extraterrestrial life. So, what exactly is the search for extraterrestrial life? Considering that humans have always been an inquisitive species, exploring and getting into literally everything that moves and doesn't move, it makes sense that a mission like SETI appeared on such a massive scale. Imagine that the universe is an incredible, immense project composed by the cosmos, but with a touch of mystery. We are the ones keeping watch for signals, more specifically electromagnetic murmurs, from developments beyond anything we could ever imagine. SETI, Search for Extraterrestrial Intelligence, resembles the world's most high-stakes game of hide and seek, with our team as the seeker and the vast universe as the seemingly endless hiding spot. It is one of those fields where scientists are like high-level Sherlocks, tuned into radio waves and scouring for that subtle "we are not alone" signal. This astronomical sleuthing started in the 1960s. Frank Drake, a prominent astrophysicist, was among the first to recognize radio transmissions from stars. It was a remarkable moment. However, no outsiders appeared at his door, at least not yet. Looking for something this huge takes patience and can span many years of work. Sometimes, not many conclusive extraterrestrial signals have been found. Notwithstanding these efforts, the excitement continues to grow as the James Webb Space Telescope keeps examining exoplanets like Proxima b. A whole field of hope is emerging. Will we accidentally find genuine proof of extraterrestrial life? Or will we simply experience eerie signals right outside our ability to comprehend, giving us more questions than answers? The discovery of lights, in fact, could mark the next chapter of humanity's timeless pursuit, where curiosity and progress merge into one massive, exciting space story. So, let's keep looking, hoping to find confirmation that we are not truly alone. The discovery of lights from distant exoplanets, like those potentially seen on Proxima b, could be a significant step toward answering one of humanity's most important questions. Are we alone in the universe? As the Webb Space Telescope continues to examine the skies, its discoveries will undoubtedly spark more conversations, investigations, and perhaps challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of these discoveries extend far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific systems. For instance, if we were to confirm that Proxima b or another exoplanet harbors some form of life, it would require us to rethink our place in the universe. Could life elsewhere evolve in ways similar to ours? Or would it present a completely new type of existence? Would it follow similar transformative paths? Or would its biology and consciousness challenge everything we know about life on Earth? Even if we fail to find direct evidence of intelligent life, the mere fact that we could detect artificial signals or lights from distant worlds would still have significant implications. It would mean that intelligent civilizations are out there, potentially capable of altering their environments in ways that are detectable from our vantage point. This would confirm that intelligent life is not an anomaly, but perhaps an inevitable outcome of specific conditions in the universe. However, it's important to remain grounded and cautious in the face of such discoveries. While the potential for finding life is exhilarating, it also raises the question, what happens next? How would we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific thoroughness? Or would the discoveries spark panic, fear, or even political battles? History has shown that humanity's responses to new discoveries, especially those that challenge deeply held beliefs, can be unpredictable. We should also consider the ethical aspects of our curiosity. If we do find proof of life, especially intelligent life, what does that mean for our responsibility as stewards of our own planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely be a central part of the conversation as we venture further into the universe. Nevertheless, the search for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents a fascinating crossroads of science, philosophy, and humanity's future.